Director of Market Transformation. Here we go. I'm Matt Rustica. I'm the Director of Market Transformation here at BDC. Today, we're going to hear from Kevin Clark from BDC member Rheem. Rheem is one of the three major water heater manufacturers in the US. And Kevin is here to talk about a revolutionary technology that Rheem has developed, which is a 120 volt heat pump water heater. Unlike other heat pump water heaters, this device doesn't require new wiring. It can be plugged into a normal electrical outlet, just a regular receptacle. There's a lot more to it than that. And I'm going to leave the details to Kevin, but we're so excited to have him here with us today. First, a little bit about us. The BDC is a coalition of energy providers, manufacturers of heating and water heating equipment, the design and construction community, local governments, nonprofits, NGOs, and others, anyone else who's working to eliminate pollution from the built environment. We do this really through working together. Coalition is a word we take seriously. We work together to devise, promote, harness the public policies and market mechanisms that are going to kind of quickly scale up building electrification in a durable way. So you can see on this slide some of our 260 some odd members. We're headquartered in California. We have offices in California and New York, but we have staff increasingly all over the US. And on this slide, you see some brief information about the many member benefits that BDC offers. We've got policy calls for California and New York. We're contemplating expanding those in the coming months. Lunch and learns, leading lights meetings with our leading lights members, and a series of special guests. You want more information about this, you can visit buildingdecarb.org/join, or you could just reach out to any of us here at BDC to learn more. Next slide, please. So BDC within the movement takes a multifaceted approach to decarbonizing buildings. We think that's appropriate and that it reflects the complexity of the task at hand, something that everyone on this call knows very well. So first, the first step is kind of getting out of the hole by stopping digging. We focused in some ways on halting the expansion of the gas network through a whole range of tactics: all electric new construction, non-pipe alternatives, as well as investigating ways to replace existing infrastructure with new non-emitting infrastructure like thermal energy networks. Second, we really need to set a date. It's critical for the marketplace that we set expectations, build in some certainty, some regulatory certainty, so that we can transform the market smoothly and deliberately, which leads me to market development. There's a lot that goes into this. In a lot of ways, it's the core of the issue. Everything from consumer inspiration to contractor engagement, distribution, incentive programs is a big deal, even R&D. It's complex, it's ambiguous, but we believe it's an indispensable part of the project. And so next slide, please. And so in 2019, BDC developed a roadmap for how to decarbonize California's buildings. We're finding that increasingly this applies in various ways to other states outside of California as well. There are a number of targets included in there. It called for an all-electric building code in California, a series of programs. It called for 100% of space heating and water heating equipment installed to be a heat pump starting in 2030, which CARB recently adopted just a few weeks ago. It's important to get a head start because this equipment can last for decades. In order to reach these targets, the roadmap includes a number of goals you can see here. First, we need to build awareness and buy-in. Electrification is still a new concept to most people, even years after that roadmap was released. People are just hearing about this stuff now in some ways. And the IRA has been a big kind of kick in the pants in that regard. The second goal, we need to make sure that customers are getting a good value in terms of comfort, in terms of operating cost. If nobody sees the benefit of electrifying, the benefit to them, then reaching the targets that we've set for ourselves is going to be pretty tough. Third, contractors and builders also need to be on board. This is a big part of buy-in. We need to use policy to make electrification the path of least resistance for builders and contractors, something that we've been engaging on pretty closely recently, especially. Fourth, we need to provide clarity to the supply chain. This is something I touched on before. It needs to have time to ramp up, it needs to have time to respond to demand, new products, old products marketed in different ways. We need to remove barriers that exist in the supply chain. Something like undersized electric panels is like this too, an infrastructure problem. And lastly, we need to make sure all our policies are aligned. clean air, energy efficiency, affordable housing, electrification. We talk about these as separate silos. In order for this to work, they really need to be all the same project. Next slide, please. A few more things before we begin. Keep an eye out for our next webinar. That's going to be November 9th at noon Pacific, 3 p.m. Eastern. We're going to be hearing about zonal electrification, which is electrifying whole neighborhoods at once. With Pacific Gas and Electric, they're a BDC member. It's going to be a great webinar. So visit buildingdecarb.org/upcoming-events for more information about this, and we hope to see you there. Next slide, please. And logistically, so everyone's going to be muted on this call. We'd love it if you could pose your questions in the chat. And at the end of Kevin's remarks, I'll facilitate a discussion about them. Also, we're recording the webinar, as you saw. Members of the coalition, which is to say members that, help me out here, Ashley, what's the decarbonizer level and above?
Early adopter and above, basically paid members of the coalition. Early
adopter and above will be able to access the recording on the website, the member portal, along with a whole range of other stuff. Membership in the BDC is easy. It's affordable. It's the best way to stay up to date with the rapidly evolving world of building decarbonization in the US and around the world. You can visit buildingdecarb.org/join for more information. And with that, I think I'd like to turn it over to Kevin.
Perfect. Thanks, Matt. Thanks for the introduction. Always appreciate the partnership with the Building Decarbonization Coalition. So, again, it's been a few years since we've been on. I remember taking a phone call from Panama those many years ago, hearing about this coalition, going, sounds kind of interesting. So it was definitely a good ad for us as we of course work with a lot of different stakeholders throughout the industry. So again, as many of you are aware, we've been talking about the 120 volt heat pump water heater for some time now. A lot of folks on this call were, in that San Francisco meeting several years back, talking about the need for a plug-in heat pump water heater. And again, it was kind of a big ask, because you're talking about having the manufacturer bring out a new product for a market that really isn't developed or has really adopted heat pumps. We see where things are going, obviously, with IRA, some federal and state and local efforts, pushing this type of technology into people's homes. But the reality of it is, we're still at under 2% of market adoption for this technology. So we're hoping that the 120 volts that Rheem and other manufacturers will be coming out with will help ease some of that adoption. And so we'll get into the technology here now. So I always like to kind of bring you back to the beginning of how a heat pump works, because there's obviously some new folks on the call. They may not have understood how heat pumps work.
Can someone move the menu bar so we can see the titles of the slides? Thank you.
I don't know how I can hide that. Well, I'll hide it there on the bottom. Does that work for you?
That's much better.
Perfect. So again, heat pumps were, pulling air through an evaporator to capture that heat out of the ambient air. That's kind of heating up the refrigerant. Then we're compressing it, going through a phase change. That heat is transferred to condenser coils to the outside of the tank, as you can see here. And then that refrigerant again is released back up into the evaporator with a valve, again going through a phase change to again capture that heat that's out of the ambient air. So that really basic process of moving heat, not creating heat, allows heat pumps to be over 400% efficient when running. So again, this is why it's important for the industry, because we're adding electrical onto already constrained infrastructure. So having the most efficient products out there, having these being able to be dispatched during certain periods of the day are going to be of value. And of course, as a water heater manufacturer, we want to make sure that we're providing consumer comfort with the products that we produce and sell. Again, this process is not scary. Everybody uses it. It's been in service for a long period of time. Think about how many old refrigerators are sitting in the garage keeping the drinks cold. This is a long-lasting technology. We obviously have it down, and we use it in a lot of different applications. So now we just need to wrap it up into water heating, and be able to ease the concerns of consumers and contractors to be able to trust this technology. So again, these integrated units have been out for a little over a decade. I think Rheem even had a split heat pump water heater back in the 80s. So again, the adoption's still not quite there. It's not on the tip of the tongue of every single homeowner, but we're certainly making great strides with a lot of the work that the BDC and partners on this call are doing. So again, obviously one of the big concerns fuel switching in California was hey, we have 90% of our homes have gas water heating. How do we get them over to an electric water heater, which typically uses a 30 amp 240 volt service for a typical tank? A lot of times these panels are constrained. We may have 100 or 150 amps available. So how do we add 30 amps when there's just not 30 amps there? Well, obviously a plug-in model would really make sense. So we went to the market. We asked consumers, we asked homeowners, plumbers, what do you think about a plug-in heat pump water heater? And, really the influencers in the market were asking for a shared circuit model. That way it can go anywhere. So we produced a shared circuit model. We put a mixing valve already on the unit. That way you can raise that set point temperature and increase capacity. But again, it's going to have a slower recovery rate because it's only using 350 to 400 watts while recovering. And it's going to produce, about 15 gallons an hour. So not a very high speed recovery unit. So that was one of the concerns that plumbers had. So, we kind of took a look at it. California has mandated a dedicated 120 volt circuit for condensing gas products into new construction for the past 20 years. What if we use some of that housing stock and develop a faster recovery 120 volt product? So that's when we came up with the dedicated circuit model as well. So again, you're taking that same high efficiency technology with the heat pump. You're just getting 3 times the recovery for it, and it'll have very similar characteristics that say a 38,000 BTU gas model that's already probably sitting in that garage has today. So that's why we came out with the 2 separate models for these units. So now I'm going to have marketing talk about these products as well. again, kind of nice marketing pieces. I definitely recommend everyone going to rheem.com/Proterra or hybrid, just to learn a little bit more about not only these 120 volt models, but the 240 volt models that we have out there in the market today. And again, that's the lure of it. You're going to take that gas line or that gas product out. You're going to cap the gas line, cap that venting, and you're going just to plumb in a new water heater and plug it into the wall and have it deliver hot water. And you're going to have it deliver it efficiently. Also, you're going to be able to deliver it when it's cheap to do so through scheduling, either through the app on the homeowner's choice or through a utility program, either using EcoNet, which is our communication platform, or through a CTA 2045 module or EcoPort module. So lots of different options out there to make sure we're putting in the right product in the right applications. Obviously, this is where a lot of training comes into place. This is where manufacturers really shine, not only with our internal folks, but with our sales agencies. Rheem's sales agency in California is Mega Western. So they have and own a lot of those plumber and distributor relationships on a daily basis. And again, you're taking a look at carbon reduction. This is a 79% reduction in carbon today. Seems pretty nice, but as we know, the grid is only going to continue to get cleaner and cleaner. So now, within the next few decades, you're talking about 100% reduction in carbon when it comes to water heating in the home. You can imagine that taking that 1 to 2 tons of carbon out per year is going to have a big impact, especially when you're talking about every single home in California and other areas of the country. Just to review on the product categories, you'll see in the top line here, we have the dedicated circuit models that come in a 40 and a 50 gallon capacity. And again, this is not going to be the right unit for every single application. So, again, going back to training with the contractors, we're really making sure that this is going to not have more than 5 folks in the home. So it'll deliver enough, hot water basically for 5 people. And again, that's with the larger capacity compressor. On the shared circuit models with the built-in thermostatic mixing valve, we get up to 80 gallons. And again, it's going to suit the needs for up to 5 people in the family. We really wanted to be in warmer climates because these do not have backup elements. Not to say that they can't go somewhere in other areas of the country, but if it is in a garage where that garage may dip below 37 degrees, which is where our cutoff is for this unit. So if the ambient air temperature gets below 37, this becomes a very large paperweight. So we want to make sure that this is going in the correct applications in the correct areas of the country. So this is a big change in how we view hot water. Rheem and other manufacturers for the past couple of decades have really been pushing this great product and tankless that provides unlimited hot water or endless hot water. So now we're moving to, well, you don't need unlimited hot water or endless hot water. You need enough hot water. So the question becomes, what is enough hot water? And again, when you look at it aggregately, it is very simple to figure out, hey, a family of 4 needs about 68 gallons of hot water per day. That means, a typical heat pump water heater has a day's worth of hot water sitting there, ready to be dispatched at any given point. Now we just have to kind of take a look at some of those peak loads and peak usage times. And again, this is going back to contractor training. Asking the homeowner, do you have a soaker tub? How big is it? Do you use it? How many people are in the home? How many showers? How many bathrooms? All those pieces of information really are necessary for a plumber to determine if this is going to be a good product for this application. They have an old style laundry machine that uses 20 gallons of hot water per load. So these are, some of the questions that we're getting plumbers prepared for, asking about, or asking our homeowners when they're recommending this type of product. Because nobody wants to have bad experiences, especially when it comes to hot water, when switching to a new, and a lot of times a more expensive technology. Again, I wanted to share something new. NIA has gone through a study of both the dedicated circuit model and the shared circuit models. And they put out a study. I will have a link here in the chat. Ashley, if you want to share that, that would be great. And again, this was prepared by NIA and Ben Larson. So for you folks that know, he's leader in the industry when it comes to studying heat pump water heaters especially. But wanted to give a shout out. NIA is always doing great work. So we always appreciate the partnership that we have with them in being able to talk about efficient water heating in not only the Northwest, but nationwide. And just kind of wanted to share some of those results real quick in case of many of you haven't seen these yet. Just to kind of set this up, they did test a 50-gallon shared circuit model and a 50-gallon dedicated circuit model. And this is kind of the results they have. They tested it in 3 different temperature variations. So they had a 50-degree ambient, 50-degree inlet water temperature test. They had a 68-degree ambient and 58-degree incoming water temperature test, as well as a summer mode, a 95-degree ambient with a 67 incoming water temperature test. So as you can see, the warmer you get, raise the efficiency, but you also raise how much water supply you get, because that delta T, or that difference in temperature, becomes lower and lower. So again, it's going to produce more hot water. Pretty nice results. Again, when it's recovering, you're getting a nice recovery rate, anywhere from a 3 to a 5 UEF on the shared circuit models, a 2.8 to a 4 UEF on the dedicated circuit models. And you'll notice that the recovery time really draws out when it is cold and that tank is exhausted. So, just think about the usage again of homeowners. They get up, they shower, they go to work and school, and they come home at night, and that tank has already been recovered for the day. If you look at the 50-degree test, think of Northern California in the wintertime. 95-degree test, think of, Southern California, maybe in the springtime. So, again, it does get hotter, it does get colder in some areas, but this is just a good representation of how these things work. Now, one note that I really want you to take a look at is when we're setting the temperature from 125 degrees, this is where it's in the low, and then raising that set point temperature up to 44 degrees. As you can see in the dedicated circuit model, we get 2 different draws in an hour. So again, those numbers get boosted up quite a bit. The supply in the shared circuit models, again, for a 50-gallon tank, if you set it at 125 degrees, you get 42 degrees of usable hot water in the wintertime in Northern California. If you set it for 140 degrees in the wintertime in California, Northern California, you get, another 13 extra gallons or an extra shower. So again, just raising that set point temperature really has a pretty big impact on supply. Anywhere from a 20 to 45% increase in supply. So this is one of the challenges that EWHI, which I'll get into in just a little bit, and some others are having, is like, hey, we have a very low rated heat pump water heater, first hour rating, because we're having the DOE tested at 125 degrees. But that's not truly the capacity, especially when you're talking about the shared circuit models with that built-in mixing valve. We can do really so much more capacity if we boost up that temperature. Now, a lot of you are saying, well, if I go from 125 degrees, that's what the UEF rating is based off of, and set it for 140 degrees, I'm going to lose all this efficiency. And really, the NIA test, shows that there really isn't a big loss in efficiency when you're raising that set point temperature. So again, this, for utilities and for, just for homeowners, concerned about their electric bill going up, raising that set point temperature isn't going to have a big penalty in efficiency, but what it will have is a big gain in hot water delivery. And of course, this is just a comparison of all site energy use for all heat pumps, all gas water heaters. And for those areas of the country that are going from electric water heater to a heat pump, it has a pretty drastic decrease in energy usage. Again, our plug-in units are tested at a higher set point temperature, so we lose a little bit of UEF. The efficiencies are the same. It's just that when it's tested at 5 degrees higher at 125. So it may look a little bit less, but again, we should be sizing our 30 and 240 volt models along with our 120 volt models, because realistically, you don't want that 4.5 kW element kicking on the 240 models. They should just be there strictly for backup. They shouldn't be a typical thing to use that element on a daily basis. As I mentioned, the Advanced Water Heating Initiative does have a field study that's going on with 120 volt products. They're testing not only our units, but other manufacturers' units for 120 volt heat pumps. We've had several installations go in, and really obviously the big one is space limitations. They are only testing the shared circuit models. Again, for families up to 5, we're asking that they use an 80-gallon heat pump. So going from a 40-gallon gas to an 80-gallon electric is going to require a little bit more space. So space limitations are there. Maybe if they were able to use the dedicated circuit models, that would help offset some of those barriers. But also, when we're doing site visits, we're relying upon consumers with their cell phones taking pictures and videos to give us an idea of where these things are going to go. Whereas if the contractor was there on site, they'd be able to make easier, quicker decisions on what product would be there and how to run certain configurations. And one thing that they've asked us to do, obviously, is publish some sort of first hour rating based on the set point temperature. So shared circuit models, again, we're testing it at 125. What is the FHR when that unit is at 140? So we're looking to be able to provide that guidance here soon. Again, Imruta and team will have an update here shortly by the end of the year. This is my heat pump water heater. Again, this is based off of my experience. I live in Las Vegas. I have an EV rate. That means I shut my water heater off in the summertime from 1 p.m. to 7 p.m. So that's a 6-hour TOU period. That's a long period of time where I'm not using that heat pump just to avoid some additional costs on the utility bill. Again, I have a family of 5. That means I have 3 kids. That means I have 3 folks that are using the bath a few times a week. So again, that 80-gallon tank is providing enough hot water, even though I'm shutting it off for 6 hours a day. In the wintertime, obviously, you see it go up. Las Vegas has, obviously a lot warmer summers, where I'm maybe using a kilowatt hour per day, but they also have a lot colder winters than California. So our incoming water temperature is colder and our ambient air temperature is colder. Just going back to that NIA study, it just means that it's going to take longer and use a little bit more energy to recover that tank. So you kind of see this bowl-shaped energy usage throughout the year for our 120 volt heat pump water heater. If you look at what utilities need resources for, especially in the summertime, is they don't need a lot of energy. They don't want a lot of energy usage in the summertime, and that's what these heat pumps are really naturally. So obviously, a lot of the water heating is going on in the wintertime when it's colder. If you average out what we've used throughout the year, it's been about 776 kilowatt hours for the year. Sorry, California, with that EV rate, I'm only at about 7.5 cents a kilowatt hour, so I'm only spending about $60 a year to heat my water. So just based off, California energy rates, that's going to vary a little bit depending on what your rate plan. That is what I had. That's the updates from the market, and obviously we're through a lot of the supply chain issues that were hitting the industry last year and the year before. So we are at a normal, healthy lead time. So these are typically right now they're on a special order. You can probably get one within 3 weeks, through a wholesale or retail distribution. With that, Matt, I will give it back to you, and we can go over some questions here.
Okay, Kevin, I'm glad you said that, because we got like a ton of questions about this. I mean, there's a lot of interest in this technology, as I'm sure you know. I'm going to try to cover everything thematically. There's a lot of kind of specific technological questions that I flagged. And I know Friday has also been taking notes. So Friday, if there's something that I don't get to that stands out to you, then please do jump in. There are a few questions about fan noise. Can you address that?
Specifically what with fan noise?
So some people noted that that the fans were slightly louder than a gas water heater when it was on. And have there been any changes to that in this ProTerra model relative to the last most recent model? And generally, what is your attitude about fan noise?
So I mean, they're designed to have a 49 decibel rating, and that's for the compressor and the fan are traditionally making those noises. There were a few louder fans out there in the market. So if you think you have one of those units, certainly reach out to warranty service. We have, we've been taking care of those under warranty. But typically, again, this is a mechanical piece of equipment, so it will make noise, and probably something more to address. It will make vibration. So again, this goes back to contractor training. We're letting contractors know, hey, if you put a vibration pad underneath the unit, if you use vibration isolation earthquake straps in California, and if you use flex hose connections at the endpoints, you're going to help not transmit that vibration into the studs of the home, where that vibration can be, come up as noise somewhere else in the house. So a lot of times, homeowners that get these units in, like, hey, I can hear this in another room. It's not really the noise that the heat pump is creating, it's the vibration that's being transmitted through the studs. So, really that vibration mitigation is something that we train on quite a bit, that we want to make sure we're addressing on the training aspect.
Excellent. Thanks for that. So let me see, I'm just trying to parse these out. So could you speak, I know you touched on this in your slides, but maybe you could put a finer point on it. There was a couple questions about, what types of units, housing units or businesses these might be appropriate for. What are the space requirements for these? Can you reiterate that, please, Kevin?
Sure. So on the shared circuit models, it's the same compressor system as the 240 volt model. So we need that 700 cubic foot of space in order to exchange out that heat. If that space is not there, again, there's lots of different options. We can get a louvered door to breathe into a hallway, or we can duct that unit, either one leg or two legs of it, depending if it's going to the outside of the envelope or not. So there's lots of different installation options for these units. On the dedicated circuit model, again, it's a 1-ton compressor, so we're moving more air. We're going to need, I'd have to confirm with the spec sheet, but I believe 1,200 cubic feet of space. If that's not available, you will have to duct the exhaust and be able to have a full louver door to bring in incoming air to that closet. So realistically, the dedicated circuit model is a good fit for the garage because you don't have to duct it. It is louder. It's 55 decibels instead of 49 because it is moving air at a quicker rate. So we on a training standpoint, we probably recommend those to be more garage focused, which a lot of California homes already have a water heater in the garage.
Okay. So one question came up, I think, earlier on in the chat about climate suitability, and as someone who lives in New Hampshire, I'm interested to hear the answer to this question as well. My understanding is that this is a model that's just available in California right now. Is that correct? And can you speak to climate suitability a little bit more detail?
Yeah, I mean, it's again, this is just the heat pump water heater. It's not a hybrid. So it's not to say that can't be ordered and installed in New Hampshire. We would probably just not recommend it based off the climate. Again, the big thing is that we want to make sure that the ambient air temperature doesn't drop below 37. Obviously, New Hampshire puts their water heaters in the basement, which doesn't really get below 50. So could it be done? Yeah. Is it recommended? Not really. I don't even think New Hampshire has a lot of fuel switching incentives anyhow. So if they have an electric water heater, they already have the 30 amp 240 service. We would really push them into maintaining that for the 240 30 amp heat pump water. So,
Okay.
I mean, that's another option. There's a lot of states, a lot of utilities that aren't allowed to incentivize going from gas to electric. So this is truly a fuel switching type product. This would not go into an electric water heater market because they would already have the electrical infrastructure there.
That's a good point, right? As a fuel switching. So Massachusetts and New York, you might have that, but not my humble state, unfortunately. Let me see. So we had one question about refrigerants. I mean, I want to bring this up. I know it's on everyone's mind, particularly for the OEMs who are kind of dealing with this shift to lower GWP refrigerants. Can you touch on that? Like what refrigerant it uses now? Is there any is that change affecting this product line?
So all the main manufacturers use R134A for a refrigerant. There's good heat transfer properties, in the typical climate band for that. So it's a good efficient refrigerant. Obviously, future regulations are making everybody to kind of take a look at changes. So we will change, along with the industry on that as well. So obviously, we have a whole group of engineers and regulatory folks that stay on top of a lot of those upcoming changes that are going to hit the market.
Okay, great. So we had a bunch of pretty granular questions about code and rebate eligibility. So I'll cycle through a couple of those if that's all right. So do these qualify for rebates under the tech program and other programs in California?
Yeah, they do qualify for tech. They have a separate 120 volt category. Energy Star does have a separate 120 volt category. I think the low mark on the UEF is 2.4, where these units are getting 2.8 UEF and above. So the shared circuit 80-gallon models, they get 3.5 UEF. So there's some programs out there that have a 3.3 UEF basement. So we would ask them to take a look at, hey, what about dropping that UEF level to a 120 volt category? It would just help adoption in that.
Excellent. Someone mentioned California plumbing codes. Can we speak to any barriers that exist there for this product in the California Plumbing Code?
You know, traditionally, if you're looking at first hour ratings, it's more of a new construction. And California is going to, really any area in the country, for new construction is going to steer to that 240 volt model in Title 24. This is more, again, for the repair replacement market. So I mean, UPC a lot of times we're obviously going to recommend, you know, having an expansion tank, you know, especially if you're looking at raising and lowering that set point temperature. You can increase the, you know, pressure inside the pipes of the house if you increase that temperature. So definitely an expansion tank. We obviously want to make sure that our installing plumbers are following all the local and state level UPC requirements that are out there.
So just to put a finer point on that, we're talking about the plumbing code applies mostly to new construction, and this is a product that was kind of conceived of as a retrofit product. Is that correct? Okay. We've just had some reiterations of some earlier questions about testing and nameplate ratings. Specifically, so are these like DOE test procedure numbers that you've been showing us?
Yeah, so the UEF that's listed on, you know, our spec sheets and all of our you know, websites and what have you are based off the DOE test pattern. The NIA study that they did, that independent study, you know, is may not account for standby loss. They're talking about the recovery efficiency of the compressor.
Okay. And so there was another question. Does the rating of the system count as a continuous load per NEC?
I would assume it does. So when you're talking about the shared circuit models, we're only allowed to have 50% of that 15 amp service. So that's you know, considered a continuous load at 50%. You wouldn't be able to go over that. I think it's about 900 watts. And then for the dedicated circuit model, you know, again, it should be by itself. We're only allowed to go up to 80% of that circuit.
Okay. Okay. So yeah, maybe a good follow on. So there was a question about how you, Kevin, are working with plumbers to get these kind of on plumbers trucks, to get these kind of in the distribution channels so that they could be used for emergency replacement. Can you speak to that? It seems like a pretty important part of rolling out this product.
Sure. I mean, obviously there's a lot of activity there. I mean, first we're training plumbers, which traditionally are very slow to adopt new technology, not the best sales folks in the world.
I won't tell them you said that.
To pick up a new technology, heat pump water heaters. So for them to, you know, try something new, to have some risk there, it's you know, it's a pretty tall, you know, barrier to get over. We're also asking the distribution chain, you know, to stock an additional possibly, you know, 6 to 10 new SKUs, you know, because each, you know, either it's Rheem, whatever the brands that are going out in California, well, we're adding another possibly 10 SKUs to a heat pump category that already has 20 SKUs. It's only, you know, again, 2% of that market. So, you know, we're trying to make sure they're getting the right, you know, fast movers in their normal ordering system. So it has taken a little bit of time. This product launched in July, so we're kind of getting into a reorder cycle with some of these distributors off of the you know, first orders they've already placed.
And have you faced any pushback? I mean, have there been any negative and frustrated feelings from anybody out there in the world about this?
Not so much. I mean, the AWHI installs have seem to have been going pretty well. Again, we're just kind of getting into that first, second cycle, third cycles for distribution of getting it into their system. So they're already pre-sold. You know, the orders that are on, you know, being delivered now are already pre-sold. So there hasn't been a ton of feedback. I mean, we've had probably 40 test sites, over the past 3-4 years. Some of those being, I think the coldest climate we've installed a test unit is in Connecticut. Again, I have one. I've had one for over a year, so I have some, pretty good long feedback. Obviously, it's pretty boring. I haven't run out of hot water. So we've had lots of different test sites in California where this product is really designed for. So far, everything, all the feedback has been pretty good. Have they utilized all the technology on it? Some consumers are a little daunted by adding a new app, transmitting some of that scheduling onto that app to their water heater. So some techies or people that are used to adopting early will utilize the technology a little bit better than others, but it's certainly available for everybody.
Yeah, with all those kids, Kevin, you must do a ton of laundry, so that's a good endorsement right there.
Yeah, heavy weekend laundry usage for sure.
You don't have to tell me twice. So we had an interesting question about manufacturing capacity. I mean, I think this is something that we've, focused on at BDC, and it's a question that we've asked of all our members. What is, if CARB confirms their, their vote that they took about 2030 kind of cutoff date, for all electric appliances, is Rheem prepared to meet demand given manufacturing capacity?
Rheem is ready. So, we are the market leader right now in heat pump technology. So we've made investments. It's kind of mind blowing the investments that Rheem has taken to increase capacity, number of manufacturing sites. So we're really taking a lead on being able to help California with its transition, the Northeast with its transition, really the nation. As we're looking at different things, NACA 4, Title 24 in California, where some of the gas bans that are going on across the country. We really want to be ready and continue to lead the industry with heat pump availability.
I'm glad we got that question in there. That's I think a lot of times the excitement and the positive side of this transition is maybe given short shrift against all the little granular issues that we face as a group. So I'm glad to hear Rheem is ready, everybody. A couple more questions, a bunch of questions continue to come in. Let me see here. Any plans on integrating a thermostatic mixing valve?
The shared circuit model already has one. The dedicated circuit model, if you're participating in a lot of the California programs like TEC or the future SGIT program, the plumber will be able to install one as well. There are some future regulations that may require a mixing valve installed in future models, all the models, but we'll have to kind of wait and see where all that plays out. That's more in the regulatory space than the sales space.
Would you call this a DIY product, or is it advisable to install this yourself?
So, I mean, if you look at the nationwide market, half of heat pump water heaters are DIY. They're sold through the retail channels, both through Home Depot and Lowe's and Menards and what have you. So the 120 volt, I will say, just personally, it's an easy model to install. You're doing incoming water to water line, outgoing water line, the condensation drain, and you plug it into the wall. So you don't have to worry about drawing that 240 volt 30 amp service over, which usually requires an electrician, which usually means another $1,500 onto the installation. So it also increases, or also adds another trade in there by having an electrician come in. Scheduling becomes more complicated. Getting that unit installed for an emergency replacement becomes very difficult. So that 120 platform is, really does knock down a lot of barriers.
Yeah, I mean, that's what makes this exciting, right? I mean, we've all been, I can't even tell you how many emails I've gotten about this thing. It's a real game changer. Related to that, if presuming you're a consumer who's already got it in their head to install a heat pump water heater, what would you say about kind of the factors that would influence whether you went for 120 volts versus a 240 volt model?
Me personally, especially if you're looking at climate like California, which is it's pretty easy on the water heating space. People move there for the nice weather, right? So I think it's an easy choice to go with the 120. You just want to make sure you're upsizing to make sure you have enough capacity to get through that time of use period. And again, you want to size your 240 volt models in a very similar fashion. You want to make sure that that element never really kicks on unless it's a real big emergency. So new construction obviously is going to have that 240 service there. So if it has the 240 service, keep the 240 service. If you are doing a fuel replacement, the 120 volt is a good product as long as it fits your installation parameters that you train on.
Okay. Let me see. So in California, there are utility programs, right, that reward peak demand reduction. Is there any meaningful difference between participating, if you're participating in those programs, between what you might be able to offer to the grid, through the connectivity capabilities of this device, in the 120 versus the 240?
They're obviously going to have a very similar value. For the utility, for the homeowner, it's going to mean a couple of different things. It's going to mean, a lower operating cost because you're not running the water heater during that peak time when when it's more expensive to do so. They usually offer some sort of bill credit, like $5 a month, or maybe they put it up front. It just depends utility to utility. So you can get some additional savings there. And then, if you combine the value proposition of having solar on your roof as well, your water heating bill is basically negated. You have no cost associated with that. You need about 2.5 panels to power this heat pump water heater throughout the year. So it's a very easy upgrade if you're doing solar on the roof to add a heat pump water heater to the value proposition.
All right. Let me see. I've been trying to pay attention here. I know we've got a bunch of questions. There are a couple questions about, space heating applications, solar thermal applications, kind of outside of just the water heating end use. I don't know, that stuff I know tends to be, case by case sort of esoteric applications. Can you speak to that at all, Kevin?
Again, when, there's a lot of folks, oh, you're going to cool your garage. Well, not really, because you're going to have a few hours of recovery going on in the summertime where that compressor is only 4,200 BTUs cooling capacity. So it's not going to cool a garage. I mean, again, I have one in Las Vegas. My garage feels no different in the summertime at all. Yeah, it will dehumidify, so you may feel that difference in the garage because of that dehumidification in the more humid summer months. But to really call it cooling is kind of misrepresenting the product. I think the hot water forum had a nice kind of example. They studied the impacts or the BTU impacts of a refrigerator versus a heat pump water heater, and they about balanced out, throughout the year. So
I was thinking about upgrading your system and using it in Ukraine where the electrical infrastructure is being bombed out. So if you put in solar panels on the top, and I gave you some information in the question in the chat about the technology we're developing, solar panels plus stationary batteries plus upgrading the sizing for the climate and tilting the panels as needed to make maximum work for you. And just so you know, this is,
I apologize, Mark. We've asked that everyone pose their questions to the chat. We're very,
I did, but
we're very happy to talk.
I was
about this.
just framing that for him.
We like to keep everything fair to everybody. Everyone's been posing their questions to the chat. Thank you.
Yeah, I mean, and realistically, just broaching that real quick. Again, this is going to have a very low wattage draw, so it is very complementary to that solar application. The shared circuit model is going to run about 350 to 400 watts. The dedicated circuit model is going to be 3 times that. So low wattage draws for sure.
Okay. Well, we're about 1 minute away from the end of our time here. Thank you so much to the almost 200, I think, people who attended today. And thank you for all the questions. This is a pretty solid engagement. Kevin, I think that it shows the pretty high level of interest in this product and excitement about what Rheem is doing. So thank you so much for being here, Kevin. Once again, thank you for everything Rheem has been doing for the decarb movement. I think that's going to be it. We hope to see you all on November 9th for our next webinar, and thank you all again. Appreciate it.
Thanks again, everyone.